Okay, this is lesson 6.1, and we're beginning our unit on trigonometry. And in our first lesson, we're going to go through what we already know. So we're going to go through a series of questions, and we're going to kind of explore things that you have previously explored in other classes. And we're going to try to summarize it all. And then on the back of this lesson, we're going to complete an investigation together about similar triangles. So to begin, the first fact we need to remember about triangles is that triangle means we have three angles, and the three angles in a triangle are always going to add up to the same total, and that total is 180 degrees. The key is the interior angles. So the sum of all the angles inside the triangle are going to add up to 180 degrees. We have four specific types of triangles. We have equilateral, isosceles, right angle, and scalene. So I've got four pictures here. One of each of these pictures represents one of these four. So let's start with the right angle triangle. It's a triangle that contains a 90-degree angle. And you'll usually see the 90-degree symbol there, the box. And that designates that that angle is 90. So we have a right triangle. This first one here says a triangle that has two sides of equal length and two angles that are equal, which means that these two sides look like the equal sides, so the angles across from the sides would be the equal angles. In this triangle, we have all three angles equal, which means all three sides would be equal. If all three angles are equal, we actually know the angles. The only way that you can have three angles add to 180, if they're all equal, is if they're 60. 60, 60, 60. This type of triangle is called an equilateral triangle. Which leaves us with our last triangle. It says a triangle that has no sides of equal length. And that means no angles are the same as well. That type of triangle, again, has a special name, and that name is scalene. Which leaves one triangle, the one on the top left, as the isosceles. So in scalene, all the sides are different, which means all the angles are different as well. Number three, what we need to know about triangles is congruency and similarity. Congruent means that two triangles are exactly the same, which means they have the same sides and same angles. So we could have one triangle that looks like this. And that means to have a similar triangle, we'd have to have the exact same triangle. We can turn it or rotate it, but it has to be identical. So all of the angles and all of the sides have to be the same. So the little ticks, if the double tick means that these two and these two sides are equal to these two sides. Single tick means that side's equal to that side, and if you have a little circle at an angle, it means that angle and that angle are the same. Similar means that you have the same angles and the same proportions. Between sides. So what's that mean? Well, that means if we had, say, this, 3, 4, 5 triangle, a similar triangle would have the same angles. So let's say that that's 1 and that's 2. Same angles. a right angle, whatever that measurement is, and whatever this measurement is, it's the same as this one, and that one's the same as that one, but the sides are going to be either bigger or smaller. We're going to scale this triangle up by double. So we're going to say 8, 6, 10. So these two triangles are similar because the angles are identical, they're equal, but the sides are just scaled up or down by a multiplier. So you can multiply all the sides by 2. We could divide all these sides by 2, make a smaller triangle. We could multiply by 5 to make an even bigger triangle, as long as it's proportional. So when we describe similarity, we use a special symbol, and that symbol is the squiggle. So if we wanted to say that triangle ABC is similar to triangle DEF, this is how we would say that. If we had this, it means that angle A and angle D are the same, angle B and angle E are the same, angle C and angle F are the same. So in number 6, name the opposite angle. In these two triangles here, we've got triangle ABC and we've got triangle CDE. If you look at these two angles, those are called opposite angles. And the reason they're opposite is because they're across a diagonal, or called a transversal. But you have two angles across the diagram between two different triangles. So they're called opposite angles. And the key property of opposite angles is that opposite angles are equal. So if we look at this diagram over here, 7, we can show that opposite angles are equal. Which angle has the same measurement as A? Well, A is opposite C. So we would say that angle A, equals angle C. And it's because they're opposites. Now you might remember other pattern called the F pattern or the Z pattern. If we use the Z pattern, I'm going to draw a Z here, a backward Z. It shows that C and E are in the Z pattern. So C also equals angle E, and that's called the Z pattern. And now that you know what angle E is, well, G is its opposite as well. So angle E equals angle G. So all of these angles, C, E, and G, are all equal to A because of opposite angles or Z pattern, or again, opposites. And you might remember that from grade 9. All right, that's all the relevant information from previous years in math about triangles. Let's do an investigation together about similar triangles. So let's flip the page. Graph the following triangles on a grid, shown labeling each vertex with the correct letter. So we're going to graph ABC first. So 2, 1 be here, and that's our A. B is 6, 1. And C is 2, 4. So we got A to C, A to B, and C to B. If I color that in, we've got a triangle. Let's try DEF, 5, 5. So 5, 5 is D. E is 13, 5. And F is 5, 11. Let's connect. Get an even bigger triangle here. So we've drawn them, we've shaded them, and now we're going to show that they are similar. Well, it looks like D and A are both right angles. And F and C might also be the same angle, and B and E might also be the same angle, so we might have similar angles. So we might say that angles are similar, but one thing's for sure, this side F to D is not the same as C to A. So different side lengths. So if we had a protractor, we could measure these angles. I'm aware that you may not have a protractor at home, so I went ahead and measured these angles previous to the lesson. And angle A is 90 degrees, so that angle right here is 90 degrees. Angle B, I measured at 37 degrees. And angle C, I measured at 53 degrees. Now what's neat is when I went to go measure angles D, F, and E, I got the same numbers. 90 degrees, 37 degrees, and 53 degrees. So it checks out that the angles are the same. So now we know that these are similar triangles because the angles are the same. The side lengths are different though. Like A to B, if we count 1, 2, 3, 4, we get 4 boxes. C to A, we get 1, 2, 3 boxes. And if we were to count C to B, we can't because it's kind of on a diagonal here. But what we can do is we can use the Pythagorean theorem because we have a right angle triangle. And I went ahead and did that previously and I got 5. So we don't have to do Pythagorean theorem. We are going to do it later in later lessons, but for now we would just count it. The bigger triangle had bigger sides. D to E was 8, E to F was 10, and D to F was 6. Now what's neat here is if we look at the ratios of the similar side lengths, we get something consistent. So if we compare AB to DE, AB to DE, the bottom sides, we get 4 over 8, which is 0.5. If we compare BC, the long one, to EF, the long one in this triangle, we get 5 over 10, which is also 0.5. And our last ones, if we compare A to C and D to F, we get 3 over 6, which again is 0.5. So if you notice, these are all the same. The angles are equal, and the ratios of similar sides are equal. In fact, they're equal as 0.5, which means the smaller triangle sides are all half the bigger triangle sides. And if we look, that's true. 8, 10, and 6. If we take half of those, 4, 5, and 3. Makes sense. So a better conclusion to number 5 is down here. Triangle ABC and DEF are called similar when triangles are similar. It means the ratio of the lengths of corresponding sides are equal. So what do I mean by that? I mean the ratios are equal. And that's what we got. We got 0.5. And the corresponding angles are also equal. What do I mean by that? I mean 90, 37, and 53. 90, 37, and 53. So that's always true of similar triangles, and this is the property that we're going to use to start solving some problems in trigonometry in our next lesson. So thanks for watching lesson 6.1, and I'll see you in lesson 6.2 where we use this idea.